Wow, maybe he's still here. Did you know that a man committed suicide after talking and being encouraged by a chatbot? That is pretty scary, right? And then we have also seen lawyers submitting wrong evidence to the court that was completely hallucinated by AI. So the more AI is used, the more opportunity there is for making life failures and mistakes, even catastrophic failures, which is true. And maybe I'm sounding a bit too dark now, but I'm actually an AI enthusiast. And I think, and I hope that many of you would actually agree with me that AI can do like tremendous good to us and to the world. And I love this saying by Professor David Wong. He said that technology is not good or evil in and of itself. It's about how people choose to use it, right? If you are arguing against AI, probably you are arguing against safe car that is not going to have accidents, well, most of the time. And this is my version. I think technology is not good or evil in and of itself. It is all about how we make sure that we can trust it. So you have to be super careful about how you build the AI system and evaluate the system. And that is where evaluation becomes a critical thing. Because I really believe that evaluation is the guardrail that distinguishes the AI system in experimentation phase and the production phase. So, good afternoon, everyone. My name is Lan. I'm an AI tech lead at Rabobank. And today I'm going to share with you my journey, my experience, but also honestly the struggles I have with evaluating the AI output. And I believe that many things that I'm going to share today, you can totally relate to it as well. Well, since the launch of ChatGPT in 2022, AI has become a shiny new toy, and everyone wants to play. I think companies just rush to adopt AI. It could be due to many reasons, like financial gains, power competitions, doing good things to the world, maybe just curiosity or people having ego. They just have to try it out. But quickly, many of them actually realize that the biggest hurdle to bring AI applications to reality is its evaluation. I think evaluation is the hardest, if not the hardest challenge. It may be like one of the hardest challenges of doing AI engineering. And in a poem by Cyprian, you know Cyprian, right? She's actually pretty big. Teams are actually spending more money on evaluating the AI's responses than generating the responses itself, which is actually ironic, isn't it? So now you're asking why it's so difficult, why is it so challenging to evaluate the AI output? There's so many reasons. Wow, AI is getting better every day by day. Recently you have this DeepSeek. It's just so good. And because it becomes so good, it is so difficult to detect its mistake. Most of us can tell like 2 plus 3 is equal to 5, but not many of us can actually solve a PhD level math problem. So if AI can solve PhD level math problem, then probably not many of us here can actually evaluate if it is right or wrong. Then you have the issue with the scale and accuracy trade-off. If you do human evaluation, it is really expensive but accurate. If you do AI automated checks, it is scalable but really limited in its performance. Then, of course, you have the hallucination issue. Because of the nature of next token prediction of this language model, like a bit of error in the next token prediction will add up, and by the time the model produce a lot of tokens, a long sentence, it can just produce nonsense. It's just like you sit in a rocket flying to the moon, and a little bit of being up a tiny bit at the beginning doesn't sound like a good deal. But over the course of a long journey, you actually end up being in the space instead of landing the moon. And then, of course, we have this non-deterministic nature of AI. You ask the same question, same prompt, everything's the same, setting the same temperature, topic, everything. But then you ask it multiple times, it just gives you different answers. So which is the raw truth, right? However, the good news is that because all of these challenges in AI evaluation, more and more research are actually focusing on this topic. If you see here from the first half of 2023, the number of research published on AI evaluation topic is actually growing exponentially. So that is a good news. And then if we look at the top repositories on GitHub, top 1,000 repositories on GitHub, more than like 50 of them actually dedicated to evaluating AI output. So there's a good hope out there that we will have like good benchmark, good framework, and that can help with evaluation of AI to make it less cumbersome, but also much better. Right, so how do you do evaluation of AI output? So this is a really like typical high-level workflow. You have the input, you put it into the LLM with a prompt. The LLM or the AI generate an output, and then you come up with some evaluation metrics to evaluate the output, right? So I really don't want to make it a lecture, but for the sake of being complete, let's just try to refresh our mind about the most common evaluation techniques out there. So you have this predictive accuracy, which is like some example of this matrix is perplexity and entropy. Perplexity, for example, it measures the ability of the uncertainty of the model when predicting the next token. So it's really useful when you need to train or fine-tune a language model. But if you are just like calling an API, then this is not your biggest concern. And then we have this similarity matrix. So for example, we have like exact match, term-based matching, or semantic similarity. So for example, if I ask you, what's up, or how are you, I'm just basically asking you the same thing, but I'm using different like word, right? So if you want to compare, you know, if the AI answer is actually addressing the user questions, you could compare the semantic similarity between the answer and the questions and see how like close they are. And this is typically done by using this kind of embedding, which is just a fancy way of saying that you can present text into a bunch of numbers, and then you compare the two vectors to see how close they are. Then, of course, you have human evaluations. This is still a like long-standing practice in evaluating the AI output. But then I think if you need human evaluation for every single output of AI, you are actually just trading one manual task for another manual task. Yeah, so that is basically killing your use case, which is why AI as a judge is becoming more and more common these days. It is really like because of its scalable nature, so people are really using it, and there are many ways that you can use AI as a judge. So for example, you can use like self-critic, basically asking the AI to review its own work. Or you can ask an AI to review another AI work. Or you ask an AI to basically compare the AI output with human output and to see if they are actually alike. So this is just like a really simple example of how you can implement AI self-critic. So you give the AI the context, you give it the user questions, and then you give it the previous answer, and then you ask, hey, can you actually review this previous answer and fix it if there's inaccuracies? So really simple, but like scalable. Okay, I know that was a little bit on the theory, but now let's go to the practicality of designing your evaluation pipeline, which is, I think, the bread and butter of bringing your AI system into production. If there's one thing that I hope you will bring home with you today, then it is really about this. You are going to evaluate all the components in your AI system. And why I'm saying this? Let's take an example of one of my projects at work. So I was using AI to basically retrieve the sustainability information from the company annual report. And then this would be my high-level workflow, right? First, I collect the data. I build a scraper to collect this annual report. And then you have to process this report, which is usually like PDF file. Or sometimes it can also be like interactive PDF file. And then like the PDF usually contains a lot of tables, but also figures. So you are going to pass it into a format that the AI can understand. So for example, Markdown or JSON. And then with that input, you feed it into the AI, to retrieve the information. So if the AI or your system fails to extract the right information, it could be like because either of one of these steps or one of them, or could be either of them, right? So if you don't evaluate each component in your system, you don't know exactly where your system fails. Let me take you an example. Here is like an example of a table in the PDF file that I need to extract the information. And also here, like this infographic, it's just even difficult for human, let alone AI. And if you look at this table again, there's no clear border. If you are just using, a standard Python package like PyPDF to pass the text from the PDF into, plain text, then what it does is that it just, it reads this table. It could read it vertically, horizontally, and without a clear border format, then the AI, actually the Python package can actually mess up the order of the information in the table. And the same for this infographic as well. Yeah, and as they say, garbage in, garbage out. It doesn't matter how good your AI is or your LLM is. It is as good as the data that you give it. So without good inputs, there's no way that the AI will give you a good answer. So what we actually did is that we spent a lot of time trying out different packages for processing the PDF file. And just by changing the package, we were able to achieve from like 73% accuracy to 80% accuracy. So I can quickly kind of show you. No. Yeah, so for example, the package I was using was like Adobe API service, and you know that Adobe invented PDF, right? So you shouldn't be surprised that they have a good package. Like on the table in the PDF will be returned when you use this API. It will be returned in a more like Excel format, which preserves the format of the table. And with that format, you can read it in a JSON like format, and then that is what you feed into the AI. It also extracts all the images from the table, from the document as well, which is super nice if you want to fit all of those images into a vision model. So that was the first component in your like the first principle that you should remember when designing your evaluation pipeline. Evaluate all the components of your system. And the second principle that I want to mention here is you are going to determine what is your success criteria. I think often the case, the hardest part is not about determining whether an output is good, but actually rather what good means. If you don't know what good means, how could you decide if something is good or not? For an AI system, maybe you can think about some metrics like answer relevant, which essentially address if the answer is addressing the user questions. It could also be factual consistency, which is about whether or not the AI is using your context to answer the questions. For example, my context says that the sky is red, but actually you believe that the sky is blue. But when the AI gives you the answer that the sky is red, you think it's wrong, but actually it's right. Because like, with regard to the context that you gave it, the answer of the AI is actually correct. So you need to think about this kind of metrics when you design your evaluation system. You could also think about the quality of the reasoning. Is the reasoning of the AI actually logic and supports the final answer that it gave you? So there are many, many more metrics. It's really depending on your use case. But often what is good for us as data scientists or AI engineer might not be good for our user. So you are going to tie your evaluation metrics to the business metrics as well, because that is what your user cares about. For example, if my evaluation pipeline say that my AI is actually like achieving 80%, factual consistency, does this mean that I can automate like 30% of my ticket support? This is what your user want to know. So tie your evaluation metrics to the business metrics. And of course, you've got to think about the evaluation method, right? All of the methods that I mentioned before. Are you going to use human evaluations? Are you going to use AI as a judge? Or you are going to combine all of them in a hybrid approach, depending on your use case and the resources you have. And then once you have your pipeline like design, you are going to ask yourself, actually, how reliable it is. And there are a few questions that I think are really good questions to ask. So if you run the same evaluation pipeline on the same data set, would you get the same or different result? Or in other words, is your evaluation pipeline reproducible? And what if I run my evaluation pipeline on different evaluation data set? What is the difference in the output, right? You have to think about the variance in the output. Are they really like big? Are they small? Are they really different? Are they more or less the same? So in general, you want to increase the reproducibility, but decrease your variance. And then a really important point, if you are going to use AI as a judge for your evaluations, then ask yourself, is my AI-based evaluation actually aligned with human evaluations? I think this is actually very important if you want to scale up your AI as a judge game. Yeah, because like, I think these days people are still using human evaluation as a North Star for evaluating the AI output. So if you want to know if your evaluation pipeline is good or not, you've got to check if it is actually aligned with the evaluation by the human. So now you are going to ask, but how can I make sure that the AI evaluation is aligned with human? So there's like a few ways you can do. And the idea is that you are not just evaluating the AI output, but you are actually evaluating how the AI can be used as an evaluator. So picture this. I have an AI output in my pipeline, and then with that output, I use another AI to evaluate that output. At the same time, I also ask a group of humans to actually label or evaluate the AI output. And with that, like two data sets, I actually compare them and see how alike they are. And in order to check the alignment, there's a few metrics that you can think about. And this is a really like excellent workflow. It is produced by Yujun Yan. It guides you about which is the right metrics that you should choose for measuring human and AI alignment. And there's a lot here, so I'm not going to cover everything in detail. Please feel free to read his blog post. It is a long blog post, but you would thank yourself for reading it. But I will give you an example of how I use this framework in my project. So remember my use case, extracting sustainability information from company report. And after I get the output from AI, I have identified these three metrics to evaluate the AI output. So factual consistency, reasoning quality of the AI output, but also the source relevance, which is basically if the AI is returning me the source that is relevant to my question. And this is a confusion matrix that I compare between the human and the AI evaluations. You can see that, there's actually a really high alignment here between human and AI for the factual consistency and reasoning quality. There's a bit of disagreements on the source relevant, but that is what you want, because you wanted to know in which part of your evaluation pipeline that the AI is not performing well yet, and the comparison between human and AI would give you that insight. So now you know that, okay, I need to focus more on improving my prompt for my AI evaluations for the source relevance, because it's not doing its job well enough. And from there, when you have the confusion matrix, you can come up with this kind of alignment metric for human and AI, like the consistency between human and AI evaluations. You can have precision, recall, F1 or accuracy. So that is just an example of like what are the alignment metrics that you can use. And even though my kind of output seems to be reasonably good, but there's one issue here. And any ideas what is the issues here? No? Okay, let me ask you questions. If you are going to buy something on Amazon, and then you have this shoe review, which one are you going to choose? Who chose the first one? No? The second one? Yes, you passed the test. Yeah, you would definitely choose the second one more, right? So if I come back to my example, I actually have really, really little human annotation data. And it's very difficult to tell if it is actually like enough sample to decide that my evaluation is good enough. So what can you do? Imagine, and this is a bit of statistics, so please bear with me. You have two evaluation systems, System A and System B, and then you wanted to see like which system is performing better when it comes to evaluating the AI output. And you calculate the mean of the factual consistency score, and you see that System B actually is performing better than System A. But then, are you actually confident that it is correct? Because I only have like 20 data points here, and maybe it's not enough. So if you want to check whether 20 data points is sufficient for the result to be reliable, what you can do is you construct the confidence interval of the mean of the score. So you create multiple bootstraps of your data set, which contains like 20 data points, and then you compute the confidence interval. As you can see here in my example, the confidence interval of both systems are a bit like widespread, and they're also overlapping. So it's very difficult to draw a conclusion on which pipeline is actually better. And if you want a narrower like confidence interval, you are going to need more sample size. So I'm going to demonstrate how changing the sample size would impact the confidence interval. So you can see here that as long as I increase my sample size, the confidence interval of the mean accuracy score is actually like getting narrower. And the more you increase the sample size, you see that there's no overlapping between the mean accuracy, right, between the two systems. And it really like back up your confidence that actually the System B is better than the System A. And then you got to decide, okay, how narrow the confidence interval should be. So that is a question you should ask yourself as a business. But this is one way to test how many sample size you need and how to make sure that one system is actually better than others. Yeah, in the end, you have something like this. So as a rule of thumb, for your reference, like 300 example is absolutely a minimum for making any meaningful evaluations. And 1,000 example is really recommended for most evaluation scenarios so that you know like how many human annotated data you need to collect to evaluate your system. Wow, I hope I managed to convince you that evaluation is hard. Actually, I think it is the hardest part of building AI applications. And it is really something that distinguishes the system in experimentation phase and production. But at the same time, at least we are safe, right? I don't think we are going to lose our job soon. People are talking about AI taking over our job, but what are we talking about, guys? We still have to do the evaluation of AI output. So at least I don't think you are going to lose our job today. Maybe tomorrow, but yeah, not today. So yeah, here is my 2 cents. I know that evaluation is hard, but it is the most important topic in AI. And not having a reliable evaluation system is a big roadblock for adopting the AI in production. I would highly recommend trying out using AI as a judge because it can be quite useful if you design it right. And don't be afraid to come back to human evaluation for the edge case. It is a long-standing practice in AI. And yeah, model tools and techniques and framework, new things are coming out every day. So I'm sure that in no time we will have better ways to evaluate our AI system. And yeah, with that, I just want to say thank you. And if you want to connect, feel free to reach out to me on LinkedIn. And I have a newsletter that I send AI news every week. So feel free to connect and subscribe.